Hey everyone, this is Aditya here, and today we're going to be dealing with infinity. Now, the reason I made this video was number one, I had a really nice day today at school, so that served as it gave me a nice bit of motivation to do this video. And number two is when many people when they progress down their mathematical careers, they would definitely encounter with this idea of infinity, and many of them, and then there are certain fundamental identities we have related to infinity, and many people do not understand these laws, these principles of infinity. So I want to clear them out. I want to clear out any doubt regarding this entire concept of infinity, and I wanted to give you a bit of an insight into how I personally view infinity and how it's helped me over visualizing all of these identities. And for example, let me give you an example. Many people say ki infinity minus infinity, it should be zero. Yeah, because any number minus itself would be zero, or infinity times times zero should be zero, because any number minus 0 should be 0. But that's not at all the case. If you would have a look through the identities say something else. So I want to help you clear all the confusion that you may have, and perhaps if like you don't have that confusion, this may offer a new way for you to visualize infinity. And it's how basically I visualize it, how I discern the concept of infinity. So, without any further ado, let's get into the video. So, first of all, before we even proceed further, you must first of all understand infinity. Remember, you must walk before you run. Yeah, and before you even walk, you have to start taking these very tiny steps. And the very reason many people aren't able to visualize infinity, why they aren't able to grasp it, is because they don't understand what infinity is. They don't and totally understand it to its core. So first of all, number one thing, infinity, it's not a number. Okay, infinity is a concept, and there is no real number as infinity. Yeah, you may have numbers like 5, 6, 7, 3, 2. You don't have a number like infinity. Infinity is first of all a concept that was visualized and made by mathematicians of their time to deal with certain problems, and it's a concept which has really helped us uh, in mathematics and physics and many other streams as well. And so first, the very primary thing is infinity is a concept. Stop visualizing infinity as a number. And then infinity is basically like this value which has no end. It is limitless, vastless, and it does not end. This value of infinity. For example, take some number 3. 3 has a value of 3. When I say 3, you think of 3. 1, 2, 3. Yeah, you don't. When I say 3, you don't go on thinking of 3.00001. 3 fixed, not less than 3, not more than 3. And same way is infinity as well. Infinity, you cannot think of a number to visualize infinity. Infinity would be a lot greater, infinitely times greater than that number. And actually, because we are discussing infinity, I should probably avoid using the word infinite for the remainder of this video. So let's go with some word endless. So yeah, so infinity would be endlessly greater than the biggest number you can think of, you can visualize. Yeah. So that is basically one very primary thing you need to know about infinity. Number one, infinity is a concept, not a number. And number two, infinity is endless. It has no limit. You cannot, have think of infinity as perhaps a certain value. You cannot pause infinity. First of all, infinity is like a body. Let's try to visualize this with physics, for example, and then correlate it with maths. So take infinity as a body. Yeah, and a body having some mass, and it gains an endless acceleration. In physics, you would probably term it as infinite acceleration. Yeah, infinity has that infinite type of endless acceleration. Yeah, so infinity, it would be a lot greater than probably the biggest thing we could have even thought of. So that is the concept of infinity. Now I'll like, edit in and share in a whiteboard. And so first of all, let us go over. I've written down seven concepts, seven identities of infinity, and they are infinity plus x equals infinity, infinity minus x equals infinity, infinity times infinity equals infinity, infinity plus infinity equals infinity, infinity minus infinity equals infinity, infinity times 0 equals indeterminate, and infinity over infinity equals indeterminate. So those are some properties of infinity, and let's go over each of them. Yeah. So the very first identity, as one may call it, or one of the principles of infinity, is infinity plus x equals infinity. And so, what does this mean? Infinity plus x equals infinity. First of all, imagine x as any variable. X can be any value, right? Infinity x can be, say, some number like 200 or 1 billion also, or 1 trillion, 1 Google, or 1 million. That x can be any value, and I'm taking the example of very high values. It can be even 1. Yeah. And if you first of all understood my definition of infinity as to what I told you it was, then you would be able to understand as to how all of this is working out. Infinity, first of all, is it does not have any value. The moment you start to pause infinity, it would keep on going on. Yeah, because infinity is a concept, it's not a number. So because infinity does not have any value, whatever we would add to infinity, it would keep on going on. Infinity will not stop. So infinity plus anything, that would make it infinity only. Then the same thing happens for infinity minus x. Yeah, infinity minus anything, it also would be infinity, because and imagine x to be any number. Let's just take 200. Infinity minus 200 equals infinity only still. Yeah, and it's the same exact thing which we're repeating on and on and on. And in fact, if you've understood this definition of infinity, then you would be able to understand all of these identities. So infinity, first of all, it does not have any fixed value, it keeps on going on. And you cannot subtract something from an endless value, right? You'd still be left with an endless value. The first two principles, first two identities of infinity. And see, it's that easy, literally. Infinity is endless, you cannot stop infinity. Think of it in that way. And it's neither, because you cannot stop it, it's not a number. Simple. That's how you can think of infinity, and it's what we will be using throughout this video. So the third concept is infinity times infinity equals infinity. Take the largest number you can think of, say 9,999,732,000. Yeah, and multiply it with another really large number, 7,292,762,548. Yeah, and when you multiply them, you'll see a really, really huge result. Okay, yeah, but infinity, remember, infinity is an endless value. It would be endlessly greater than whatever number you can fathom. Yeah, so that's why infinity, which is it's an unending value. An unending value times an unending value is equal to an unending value. Same way, an unending value plus some number equals an unending value. An unending value minus some number equals another unending value. Yeah. So moving on to the fourth principle or law. Infinity plus infinity equals infinity. Now, remember, you'll be doing the exact same thing here also, which you did for like the third identity. Some endless value plus another endless value equals another endless value. Infinity cannot be stopped. You cannot think of infinity as something like, say, 1 billion plus 1 billion equals 2 billion. See, because 1 billion has a value, it stops at 1 billion. You cannot call 1 billion as 999,999,999.99999. 1 billion is 1 billion, and 1 billion is not 1 billion point 0.000000001. Yeah, but infinity is the totally opposite thing. Infinity has no value, it has an unending value. Okay, so infinity, addition of anything to infinity, it will not change the result of whatever infinity. Addition of anything, so infinity plus addition of infinity, it will be still infinity. And the exact same thing happens for the fifth identity, which is infinity minus infinity equals infinity. And this is a really interesting one, because many people, they start saying ki infinity minus infinity, it's zero. However, see, they violate the very first basic thing which I like maybe mentioned about in my definition of infinity, or how I visualize infinity, and that is infinity is not a number. Infinity is an endless value, and some endless value minus another endless value. You cannot, at first glance, it may look to be zero. Yeah, but think of it this way. Now, let's get our physics example back. An object having an infinite acceleration, would you be able to measure out its velocity at any instant? No. And just in that value, an unendless value, you will not be able to pause that unendless value and put it into this equation, which is infinity minus infinity equals infinity. So that is why, because you cannot have any value for infinity, that would be because you cannot, you cannot pause infinity or put some value for infinity and then subtract it from infinity. That's why infinity minus infinity, it would always be infinity and not some value like zero. Okay, moving on. Yeah, now this is an interesting one. Infinity times zero is indeterminate. Now, take one very interesting thing. We know that anything times zero, it equals, zero. However, if I say ki infinity times zero is undefined, because infinity itself is an undefined number, it has no finite value. If you have something which has no finite value, how will you be able to multiply it via zero? And so the entire concept of multiplication of zero with anything, with any number equals zero, that gets eliminated here, because infinity is an undefined number, it has no value. Same thing, see, if you're like listening to what I'm saying, then you may be thinking ki I'm just applying the same principle over and over again, I'm just saying the same thing ki infinity has no value, how would you be able to subtract, how will you be able to pause infinity and do some operation on it? And that's exactly the point. If you've understood the basic concept of infinity, these identities, they are actually pretty easy. And coming back to our infinity times zero dilemma, infinity is an undefined number. So any multiplying any undefined number with zero, it results in an undefined value. So that's why it's indeterminate. And you'll apply same exact principle to the seventh one, which is infinity over infinity equals indeterminate value. Just you will not be able to pause this infinity, would you be? Yeah, you will not be able to like get some or a certain value for infinity. You'll not be able to get a value or some finite expression for infinity. So that's why infinity over infinity equals indeterminate, and many people they think infinity over infinity it becomes 1. In the same example, like infinity minus infinity equals 0, because infinity is not at all a real number, it's just a concept that we humans made up for our own purposes. So infinity over infinity, it is an indeterminate value, because remember infinity is an undefined number, and because it has no finite value, infinity would not simplify itself to be 1. It keeps on going on. It is endlessly bigger than probably the largest number you could fathom of. So that everyone, that is thank you everyone. That is it for my explanation of infinity, and probably like I've helped you out enough so that you can go on and visualize these identities by yourself. And I hope that you would be able to get or grasp an idea over the concept of infinity. So thank you very much for watching. Bye.